Has anybody done any Kotlin at all?
I've read the manual, that counts.
Excellent. Oh, that works. You can tell me when I got it wrong. This is good. I was hoping he was going to be able to get away with bluffing, but now you're going to keep me honest. So, okay, has anyone heard of Kotlin? Nice, that's good. That's good. So, from the website, Kotlin is a statically typed programming language for modern multi-platform applications. Cool. What does that really kind of mean, though? It is a programming language. Which we have written, which JetBrains has written. I'm going to stop saying we. Whenever I do this one, I say we, and it's not me because I've got nothing to do with any of this. This is a completely separate team. And JetBrains basically needed a new language. We started it in 2010. And at the time, sort of Java itself was kind of a bit stagnating and not doing very much. And we've got a heavy investment in Java. IntelliJ itself is written in Java. All of the other IDEs, which are based on IntelliJ, are written in Java. Our server-side tools, UTrack, UpSource, TeamCity, are written in Java as well. And so we kind of wanted to use a more modern language which we could use to build stuff and go forward and be more productive and all that kind of stuff. And so in the end, we looked at various different languages, and in the end, we decided to write our own. And there were a few sort of guiding principles to this. We wanted it to be concise. So Java is a little bit renowned for its boilerplate and its verbosity, and so we wanted to kind of get rid of some of the ceremony around writing JVM-based code. We wanted it to be safe. Obviously, we wanted the type safety that you've got in Java, and if we could improve on that, that would be even better. It has to be very, very interoperable with Java because we've got a big Java investment already, and we don't want to have to sort of stop the world, rewrite something in a new language, and then carry on again. We wanted to be able to seamlessly integrate and work well there. And obviously we build tools. We want it to be tool friendly. We like tools. We believe in IDEs, so we want it to be very IDE friendly. But more than that as well, it's like, why would you be interested in Kotlin? Why would you like to look at this? And the first thing is looking at the sort of targets that it supports. So everybody, I presume, knows that it's a JVM-based language. So you can use it to work with your Java apps or as standalone as a JVM application. But it's also supported on Android. It's also supported as JavaScript in the browser. So we do multi-targeting. We target different platforms, and we can target the JVM. We can target Android. We can target the browser with JavaScript and Node indeed. So we don't have to be just in the browser. And we can also target native code as well. So Kotlin is very versatile. It's got a very good multi-platform story. This was kind of built in right from the start. The idea was that we would have multiple backends, and so the language would be able to target different platforms as time goes on. So basically, it gives you a lot of reach. You can use the same language on any platform you want it to be. What's really cool is things like Android and native allows you to share code with mobile applications. So you can have a mobile application with your core library written in in Kotlin, and have it work on Android and have it also work on iOS. And then you can write then sort of UI specific parts and plug those in as you see fit. With Kotlin native, you can actually target Android native as well, so you don't have to use the sort of JVM side of things as well with that. Native is still in development. It technically works. What we are building on now is the multi-platform story of being able to sort of have a good way of targeting multiple platforms. Its JVM heritage shows in the fact that you need to use Gradle to build these files, and Gradle's an interesting beast. So we can do that. But native allows us to target lots of things really: Windows, Mac, Linux, iOS, Android. WebAssembly as well, which is interesting, and also things like the little embedded boards as well, so you could do Internet of Things type development. It's basically LLVM based, so you can target pretty much anything. So this is what we're going to have a look at. This is kind of the Kotlin kind of thing. Just kidding. That's not everything. We're not going to have a look at that. So what we'll do is we'll have a quick look at a few things. This is some Java code, and yes, it's a little bit verbose. It's a very simple class, believe it or not, which has got some getters, some setters. It has equality, hash code, toString, and a lot of ceremony. That's the same class in Kotlin. So it's a little unfair perhaps on Java. You can do things there to make it look a little nicer there. But this is what we can do in Kotlin. This introduces a few interesting things. We've got modifiers in Kotlin. There are modifiers which you can have on classes and functions and things, which allow you to change the way that the compiler works with the code that you've got. So the data modifier we've got here actually generates all of that boilerplate that the Java class has. So it generates getters and setters for you. It generates the toString, the get hash code, and so on like that.
Just saying, but you overrided the toString. You weren't using the null one, were you there? So.
In this instance.
Yeah. So I was just, you weren't, but it is already there for the Java code. That's just overridden it to your version of it.
Yes.
Yeah.
Yes. So this is the one which will then output information from the current class rather than the base class. So the base class wouldn't output all of the fields that I've got on this class.
All right. Okay. So that's what the Kotlin version would do.
Yes. Yes. Exactly. Sorry. So the Kotlin version will effectively generate this kind of a toString with the information from the properties there. So it would be able to, the Kotlin generated code here. The toString would output the ID, would output the name, it would output the email address. The hash code and equalities would also compare those fields as well. So this would be treated like a value class. And comparisons there. If you had two instances of this class with the same parameters, then the equality would be true because it's the same values. Does that make sense? Okay, cool. Other things which are interesting about this little code snippet is introduces the idea of a primary constructor. So again, it's trying to be concise. So instead of having to have curly brackets and a separate constructor and everything, shove it all on the one line, and it can specify everything in there. And we've actually can define public properties here as well. So we can use the val and var keywords here to define a property. If we wanted them to be private properties, we can use the private keyword and keep them private. If we wanted them to just be parameters to the constructor, we can take off the keywords and it would all work there. All concise in the same constructor. Val is a keyword which means it's immutable. It's a value rather than a var, which is a variable, which is mutable. And by using those keywords, then it'll generate the properties with getters and setters as appropriate there. So obviously, the ID would have a getter but no setter, whereas the mutable properties here would have setters as well. Creating a new instance is interesting because you don't use the new keyword. You just call the constructor. So one of the things with Kotlin is that it's, I hesitate to say functional, but it's functional. So it's not functional like F#, it's not a functional programming language, but functions are a big deal in Kotlin. They're everywhere. And constructors are no different. So constructors is just a function. You call that, you get an instance back. The other thing to point out is that there is type inference. You're all familiar with this with C#. If you start using, if you use C#, you'll very easily slip into Kotlin. It's really quite nice to use. The hardest part is going to be learning the JVM eco structure for your ecosystem for your libraries. But what tends to happen is that you get so used to val and read-only type things as you try and use it back in C#, which is a pain. And you also drop off semicolons because semicolons are optional as well. So yep, it's all statically typed, just like C#. It's all good. Here's a slightly bigger example, and you can see the Java heritage here in things like package and import and so on. Package, that's equivalent to namespace in C#. Import is equivalent to using, so actually it's not that big a deal. We've got a class, we've got a primary constructor on there. We've got a property defined in there, val area by lazy. We can have delegated properties. So we can actually just say, lazily evaluate this property here, and that's extensible as well. So that's a nice way of working there. You can define a property with a getter and a computed property with height is equal to width. Functions to call a method, inheritance, and all fun stuff like that. One of the key things as well with Kotlin is that everything is an expression, so you don't tend to get statements. So in C#, for example, console.writeLine is a statement. It doesn't have a return value. You don't have that in Kotlin. Everything has a value. Everything has a return value. And apart from an actual declaration itself, declarations are the only things which are. So you can actually assign an if statement to something, because that actually assigns the result of the if statement. And so if you want to have that, if A is greater than B, have it to A, otherwise it's set to B. This is true for things like when, and also for throw as well. Throw is an expression, which is good. They always return a value. So throw is an interesting one. I'll come to that in a sec. So you can still call it like a statement, so you could still have the equivalent of console writeLine, but the return value is then just ignored. And some of them then you can sort of flag to say you can't ignore this return value, do something with it. And also the last expression is the value of a block, so you don't need to always use return, so it can be quite terse. So yay, type system time. Sure you'll be waiting for that one. The type system is interesting. There's no void keyword, because void is just weird. You can't you can't use it. So in C#, for example, you can't have a list of void. That's just weird, or like a function of void. It makes no sense. So void is not a type. Void is an absence of types. So Kotlin doesn't have that. Instead, it has unit instead. And unit, there's only one instance of unit, and you can use that around. But now you can use that in generics and everything. It makes it much more useful. The root type is any rather than object, and this is where you could immediately think that the root type is going to be object because of its JVM heritage, so java.lang.object. But of course it targets JavaScript, native, Android, and so on. So having java.lang.object as the root object would also be weird, and so it isn't. So we've got any as the type there. That can, when run under the JVM, that does map to Java's object, and it's effectively a facade for it. There's also the nothing type. This is kind of like where any is the root at the top here, nothing is the leaf element, which is weird because it kind of derives from everything, which is, again, quite weird. But if you've got a method like this, a function like this, which throws an exception, but where everything has to have a return type, how do you declare that? Because it doesn't actually return anything, because the program's going to abort at that point. So what you have is this idea of nothing, and that actually then tells the caller that this method is never going to return. So that's useful for things like asserts, because if it's going to happen, it's going to return nothing, and you can say, well, this code here is not going to run any further because you've got a nothing type going on there. Other useful things about the type system is that it will hide, if you're running on the JVM, it hides the weird primitive and wrapper type things. So the JVM has int and integer, which is equivalent to C#'s boxing of int and so on. That all gets hidden away for you. You don't have to worry about that. There are functional types, there are nullable types as well. Nullable's good. And there are generics. I don't want to talk too much about this because, yeah, it gets there. Just know that they're there, and it's kind of based on the Java idea of type erasure. So you lose information about what the generic type is. So that's the key thing there. There are constraints like in C#. There's weird things like star projections, declaration, site variants, and rarefied type parameters, but we're going to completely ignore those. If you want to know more about that, then feel free to read up on those. Another cool thing with a type system is the idea of smart casts. So the compiler knows about the data flow, the control flow of the program, and it knows when you're checking types. So here we've got like a bit of a pattern matching. We've got x being passed in, it's of any type, so we don't know what type it is. We can use the pattern matching argument when to say when it's a string, and then I can immediately call x.starts with, because the compiler says, oh, it's a string. X is now a string. So we don't have to say when x is string s dot starts with. You can just say, well, I know that x is a string, the compiler knows that x is a string, let's use it as a string. And that's surfaced in the UI as well. So that's then sort of called out to say that you've got a smart cast going on here. Null safety. This is really, really cool, and I can't wait till C# gets something like this, although it's not going to be quite as strong, unfortunately. So the idea of this is everything is non-nullable by default. So you have to say when something can be nullable. So if you have a string, it is always a string. It cannot be null. You have to have a nullable string for it to be null. So in this example here, we've got a variable a, and I can do a.length, and I get that value, and I know that is actually going to have a value. If I try and assign null to a, it's a variable, it's fine, I'm going to get a compilation error because it says you can't assign null to a non-nullable string. So that's good. So you've got some compiler-driven type safety going on there. You can, of course, have nullable types, and so you have string exclamation mark, which I really like. Is that string? Just like the way you pronounce these codes. If you're reading this code, string, what? And so now I can assign a null to b because it can be a nullable string. But when I try and call it, if I do b.length, I'll get a compile time error because you can't call b.length because it might be null. You know it might be null. I know it might be null. The compiler knows it might be null, so don't do it. Instead, you use the question mark dot operator. But this kind of lifts the nullable through now because the type of L2 is now a nullable int. Because it might be an int as a value. If b has a value, it will be an integer. But if b is null, it will be null instead. So it kind of, the null propagates through like that. You can also use the double exclamation mark, the runtime assert operator. I can't remember its proper name. There's people call it the dammit operator, which is a good one. And that will just say, I know that this is not going to be null. Just do it. And you can get a runtime assert this time. The compiler will say, fine, you know best, and go for it. Basically, you probably don't know best. Don't do this. Do it properly. It's good. But also that one is like B. So, string. It's all in the pronunciation. Interop for null safety is an interesting one because, of course, we've got a huge amount of the JVM ecosystem or JavaScript or native or whatever, which is not going to know about nullability. So how does this work? How do we solve this one? And the idea of this is that if you have an API that is not sort of Kotlin based and explicitly states its nullability or non-nullability, it's treated as unknown. It's treated as a platform type. This can't be expressed in source. You can't declare a platform type, but you can sort of consume them, and there are no guarantees here whatsoever. So basically, it would be nice to be able to say everything is nullable unless told otherwise, but then you just get a ton of warnings, and it's a bad experience. If you flip it and have it the other way around, it's not safe, so you can't do it. So basically, you have to go for it. And what happens is that you then convert it to a particular Kotlin type, and you can say, well, I know this is going to be non-null, so I'll just say it's non-null, and you'll get a runtime assert if you're wrong. You can also add on annotations to those APIs as well to explicitly say what they should be. I'm going to run out of time. This is terrible. Right, so let's have a quick look at functions. Functions are everywhere. You've got class functions, and you can use the modifier, the open modifier there, to sort of say that it can be overridden, and it can be derived from an overridden. You can use the override modifier as well to set it. You can have default values like you can in C#, and you can also be sort of quite terse with those as well. So. You can have top-level functions. That's a very good point there. So that double function there is a top-level function. It's outside of a class. So you don't have to have a class wrapper around it. You can just put it at the top level. Everything's within a package anyway, within a namespace. So things are appropriately scoped. And it's effectively then like a static function. So you don't have to have a static class anymore which holds these things. You just have functions. And it's just nice. And that's actually really nice when you come to interoperate with native code, because you talk to libc, which is a whole load of C functions, and you don't have this weird arbitrary static class. You just have top-level functions, read, write, and fstat, and so on. And you can see the type annotations there as well. They come after the name of the thing, and you can actually start to be a bit more terse as well. So you don't have to have the curly brackets if it's a really short expression, and you also don't have to have a return value explicitly specified if the compiler can do type inferencing for you. So you can be quite terse. Local functions as well inside another function. It's nice and cool. Quick thing on function modifiers. We've already seen open and override. There's another one which is tail rec for tail recursive stuff. this tells the compiler to rewrite the code in a similar way to the data annotation told the class to rewrite it, to add in the getters, setters, hash code and toString and so on. This will rewrite this from being a tail recursive calling itself thing into a iterative loop which doesn't do recursion. So that's going to help you with your stack type stuff. You can also have an infix notation. This is called for a method here where you've got sort of a.to and that. Well, let's have a look at the example down the bottom there. We can call this a.to1, or we can do b.to2. So we can call it as an infix way and call it sort of in between the two parameters there. And this is a nice way of writing, and it's useful for making domain-specific languages and so on. And I'm going to finish on this one, I'm afraid, sorry. One thing you might have noticed is the weird syntax going on here with a.to. It's like, what's that all about? And this is the idea of extension functions. This is kind of like extension methods in C#, but it is a slightly different syntax. Rather than sort of explicitly passing in a first parameter, which is this that you're extending, as it were, you specify the type as part of the method signature. And so this is going to be a extension function swap on mutable list of t. Takes in two parameters, and there is a implicit this keyword, which is the value of the thing you're extending. So this is very much like the syntax sugar that you get in the C# compiler, but without having to explicitly add on this parameter, which you do. You have the implicit this. And that is what's going on in this little thing here. A.to means that I am extending a generic type, A, to have a method a function 2, which takes it in there, and I'm passing the this in there. That's the implicit thing there. So I'm using this to create a pair. And you can also then, because of the way this syntax is laid out, you can do something which C# can't do, and you can have extension properties. And so you can actually have a property which is an extension value, because C# requires parameters, and so you can't have a property going on there. But here you can specify the type and say list of t has a new property last index, which with a particular getter. Extension properties are a little bit interesting because you can't have data in them. They are effectively static functions. You know, that's how you can think about them. So you can't add data to a class, but you can do sort of computed properties and work with data there. And I'm afraid I'm going to have to leave it at that there. We reached the 8:30 stage. So I'm sorry about that. If I will, let me just see. Let me just get on to, where are we? Last couple of things then. If you want to try it, let's skip to this one. If you want to try it, you can try it online. You can go to kotlin.org. You can download IntelliJ IDEA and use it, or Android Studio, because Kotlin is supported in Android by Google as a first-class language. You can even use it in Eclipse. We have a plugin for Eclipse, or as a command line compiler. If you use try.kotlin.org, there is a browser-based version where you can have a whole bunch of examples which you can run in the browser and work with. And also the documentation has a load of examples, and the examples themselves are clickable and runnable in the browser, which is pretty cool. Instructions for working with the thing there, and then there are some links there for it. And apologies that this was cut short, but thank you.
Thanks again for Matt for coming up. You can disappear if you want to.
I'm going to have to, sorry.
It's all right.